Hi, I'm Paul. This is Science That Sticks. Everything you need to know about giant covalent structures. Roll the graphic. So in this session, I'm going to talk to you about the three giant covalent structures: diamond, graphite, silica. It doesn't matter which way round we talk about these, but we need to describe and show or sketch each of those as structures. We need to describe their properties and we need to explain their properties, normally using the bonding that is associated with each of the three structures. Easy enough to say, not so easy to do. So let's look at how we draw diamond. We start off with one carbon atom, three coming off at different angles, so it gives the impression that we've got one carbon atom coming out, another going back, and one sticking out the top. We then continue the pattern. Quite often you're given one of these and asked to continue the pattern or show or describe or sketch the structure. And there you have it. It's not exactly difficult and it's not exactly pretty, but it will get you the marks. So what are the key things about diamond? Well, it's hard. It has a high melting point. It has a high boiling point. It does not conduct electricity and it does not conduct heat. Those are the descriptions of the physical properties. It's also unreactive. Now let's explain them. First point. There is no intermolecular forces that are weak and can be easily overcome. There just isn't. 2. The only thing holding the atoms together are strong covalent bonds. These require a lot of energy to be overcome. Therefore, they have high melting points, high boiling points. Lastly, it is a bad conductor of heat and bad conductor of electricity because there are no free charged particles. There are no free electrons, there are no free ions. They are all covalently bonded. That's that. I start off with a hexagon, but sometimes I just draw little circles at each of the points just to show that they are carbon atoms. So now we've got two layers. It is important for you to state and show that graphite has two layers. They can slide over one another, which is what makes it ideal as a lubricant. It also doesn't happen to be as hard as diamond, but it will conduct electricity and it will conduct heat. And the reason for this, it has delocalized electrons. So where we've got these carbons, each of the carbon atoms is bonded to two others. So there is a set of 3 carbon atoms. The electrons that are left over are delocalized and they're placed in between the 2 layers, allowing them to be attracted to one another. Because there are delocalized electrons, this means there are charged particles that are free to move. They're not charged ions, they are electrons. Because they are electrons, they are free to move. It will conduct electricity. It's still got a high melting point, it's still got a high boiling point because it contains only covalent bonds, and these are very difficult to overcome because they require a lot of energy. Let's now look at silica, or silicon dioxide. Now in this case, very, very similarly to graphite, we've got one atom and it's surrounded by 4 others. But in this case, for every 1 silicon, on average, there are 2 oxygens either side of it, which is why it has the chemical formula SiO2. It has a high melting point, it has a high boiling point, it does not conduct electricity and it does not conduct heat. Why? It only has strong covalent bonds. It has no weak intermolecular forces. And because it contains only strong covalent bonds, these require a lot of energy to overcome them and therefore melt it, boil it, and so on. There are no free particles that are able to move that are charged. Let me rephrase that. There are no charged particles that are free to move. That means there's no delocalized electrons. There are no ions. It cannot be dissolved. Similarly, graphite cannot be dissolved. Similarly, diamonds cannot be dissolved because they are not polar. They cannot get in between water molecules. That's it. That's all you need to know and everything you need to do about giant covalent structures, diamond, graphite, silica. Until next time, go in peace. Stay cool. Bye-bye.